before we prove that the given limit of a certain function is true, using the definition of the limit of a function, let's define first what a limit of a function is. It is defined as, let f be a function defined at every number in some open interval containing a. So let's say we have an open interval Mn, and a is an element of this open interval, okay? And the function is defined within this given open interval. Now, except possibly at the number a itself. So the limit of f of x as x approaches a is L, and which can be written as this. And it can be read as the limit of f of x as x approaches a is equal to L. Now, this equation is true if the following statement is true. And that is, given any epsilon greater than 0, however small, there exists a delta greater than 0 such that if the absolute value of x minus a is greater than 0 but less than delta, then we can find an epsilon such that, or an epsilon which is greater than the absolute value of the difference of the function value and the limit L. Okay, so that's the definition of the limit of a function. Okay, now let's apply this definition in proving that the given limit of a certain function is true. In problem number 2, we will use the epsilon delta definition of limit to prove that the limit of 2x minus 5 as x approaches 3 is equal to 1. So here, we're going to find a delta in terms of epsilon such that it will satisfy the given it satisfies the given definition of the limit. So here, we will start from, okay, our proof will start from, we let epsilon to be greater than 0. And we want to find delta greater than 0 such that if 0 is less than the absolute value of x minus 3 is less than delta, which is this, okay, then by definition, then we know that the absolute value of 2x minus 5 minus the limit, which is 1, is less than epsilon. So here, we will be using, okay, let me just change. We will be using this statement or inequality to find the delta, okay, to find the value of delta. So let's use this inequality. And we need to express this inequality or absolute value inequality in this form for us to find the value of delta. Now, let's simplify this expression or inequality, absolute value inequality. We have 2x minus 6 is less than epsilon. And if we're going to simplify this would be 2 times x minus 3 is less than epsilon. And we could factor out 2, so that's 2 times, or absolute value of 2 times the absolute value of x minus 3 is less than epsilon. And since the absolute value of 2 is 2, so we have 2 times the absolute value of x minus 3 is less than epsilon. And we can divide this by 2. And this becomes the absolute value of x minus 3 is less than epsilon over 2. So in this case, now we could say that, okay, let me just change the color of the pen. We could say that with the use of the given here, okay, we have already x or absolute value of x minus 3, absolute value of x minus 3, and the less than, and the less than, and we have delta, and we have the epsilon over 2, which implies that delta is less than epsilon over 2. Okay? Oh, sorry. It's supposed to be equal. All right? So it's supposed to be equal. Okay, pen color red. All right, so let me write equal sign. So we have already found the value of delta in terms of epsilon, which is equal to epsilon over 2. Now, what we're going to do is step number 2, wherein we're going to show that there exists an epsilon, okay? There exists an epsilon, okay, which is less than the absolute value of 2x minus 5 minus 1, all right, given the value of delta, which is epsilon over 2. Again, we're going back to the proof, okay, saying that for a given epsilon greater than 0, however small, there exists delta greater than 0, and we already found delta. And our delta that we found was delta is equal to epsilon over 2, right, in a given problem. And we will be using this to show that this exists, okay? And what do we mean by this? There exists an epsilon which is less than the absolute value of the given function minus the given limit, all right? So here, we're now going to use uh, the given, or I mean the value of delta that we found. So in step number 2, in proving, okay, let me just change the color of the pen to white. So again, we found that delta is equal to epsilon over 2, okay? So it is stated, guys, that epsilon, sorry, it is stated that epsilon, for every epsilon greater than 0, there exists delta greater than 0 such that, okay, the absolute value of x minus 3 is greater than delta, I mean less than delta, greater than 0, then, okay, we need to show that 2x minus 5, okay, minus 1 is less than epsilon. So again, we want to show that epsilon exists when the value of delta is epsilon over 2, okay? And how do we do that? Of course, we will be using the given, okay, the premise of the given statement. So here we already identified the delta here, and we have already identified this, all right? So here, we're going to start from this statement. So we have the absolute value of x minus 3 is less than delta. And we know that this is greater than 0 because it's absolute value, okay? It could be greater than or equal to 0. Okay, now in this case, um, we're going to find a way such that this inequality or absolute value inequality expression could be expressed in form of this. All right, we could express it in the absolute value of 2x minus 5 minus 1 is less than delta or whatever, okay, for us to find the value of epsilon, okay, or for us to show that there exists an epsilon here. So what do we do with this? Now, for us to express this in terms of this, since this is 2x, then I could, or I need to multiply this by 2 such that this becomes 2x. So I could multiply both sides by 2. So, sorry. So this is, okay, let me just erase. This is not 2, it's supposed to be x. Okay, white. All right, so this is x minus 3 is less than 2 delta. Okay, why 2 delta? Because we multiplied both sides by 2. And since 2 is equal to the absolute value of 2, all right, so I could say absolute value of 2 times the absolute value of x minus 3 is less than 2 delta. And let's move on to the next. We could say I could, okay, multiply So 2 times x minus 3 absolute value less than 2 delta. So here, I could simplify this. 2x minus 6 is less than 2 delta. Again, our main goal is to express this in terms of this because this is our conclusion. And we need to show that there exists an epsilon which is greater than this. So the absolute value of 2x minus 6 could be expressed in this form. We have 2x minus 5 minus 1 is less than 2 delta. And I have already expressed the left-hand side of the inequality uh, with the same as this. That's the absolute value of 2x minus 5 minus 1, right? And however, the right-hand side of the inequality is 2 delta. And we should express it in terms of E to show that there exists an epsilon greater than this, right? So what do we do with this 2 delta? We know that delta is equal to epsilon over 2. So we can substitute the value of delta here. 2 times epsilon over 2. And I could cancel out 2 here, and this becomes epsilon. So we can write this as the absolute value of 2x minus 5 minus 1 less than epsilon. So we have already proven that there exists an epsilon, okay, when delta is equal to epsilon over 2, such that epsilon is greater than the absolute value of 2x minus 5 minus 1. So in this case, okay, using the definition of the epsilon delta definition of limit, then we have proven that the limit of 2x minus 5 as x approaches 3 is equal to 1. Okay? So I hope everything is clear. Now, if you have questions, you can make comments or post your questions on under this video. Thank you.